What if the universe had hidden doorways, places where you could step in and instantly emerge on the other side of the galaxy, or even in another time? These doorways are called wormholes, and they've captured our imagination for decades. But here's the big question: are wormholes real, or just science fiction? Stay tuned, because what you're about to learn will bend your mind. To understand wormholes, we first need to revisit Albert Einstein's theory of general relativity. Einstein showed us that space and time are woven together into a single fabric, space-time, and that fabric can bend under the weight of gravity. Now imagine space-time as a giant sheet of paper. Normally, if you want to get from one point to another, you draw a line across the paper, but if you fold the paper and make the 2 points touch, suddenly you've created a shortcut. That shortcut is what scientists call a wormhole, a tunnel connecting two distant points in space and time. The math actually supports the idea. Einstein himself, along with physicist Rosen, proposed the concept of a wormhole in 1935. They called it an Einstein-Rosen bridge. In theory, these bridges could allow instant travel between faraway places. Instead of taking thousands of years to cross the galaxy at light speed, you could simply step through a wormhole and arrive almost instantly. But there's a problem: wormholes, if they exist, would be incredibly unstable. They would collapse faster than light could travel through them. To keep one open, scientists believe we'd need something called exotic matter, a strange form of energy with negative mass. So what exactly is exotic matter? Unlike normal matter, which has positive mass and attracts, exotic matter would have negative mass and repel. If placed inside a wormhole, it could counteract gravity and keep the tunnel open long enough for something to pass through. There are even small hints of this in physics. The Casimir effect, observed in quantum mechanics, shows that strange negative energy states can exist between very close surfaces. It's not exotic matter yet, but it tells us that the building blocks of wormhole physics may already be hiding in the quantum world. Here's where things get even wilder. If one end of a wormhole moves differently through time than the other, say one is near a black hole where time slows down, then stepping through it could be like stepping into the past or the future. In other words, wormholes might not just connect places in space, but moments in time. That means wormholes could, in theory, be natural time machines. Of course, this raises all the classic paradoxes: the grandfather paradox, the bootstrap paradox, and endless questions about whether history could be changed, or if new timelines would simply branch off into a multiverse. It's no wonder wormholes are a favorite of science fiction. In Interstellar, wormholes are used as cosmic shortcuts to distant galaxies. In Stargate, they're portals linking entire worlds. Even Marvel's Avengers Endgame use wormhole-like physics to explain time travel. These stories excite us because they take real scientific equations and stretch them into thrilling adventures. But behind the fiction, the idea remains rooted in serious physics. So, do wormholes actually exist? Right now, we have no direct evidence. Astronomers have never observed one. But the universe has a way of surprising us. Black holes were once just theoretical too, until we photographed one in 2019. Some researchers suggest wormholes could be microscopic, appearing and disappearing constantly at the quantum scale. Others believe that if giant wormholes exist, they might look almost identical to black holes, hiding in plain sight across the cosmos. Physicist Kip Thorne, who won the Nobel Prize and advised the film Interstellar, even explored the mathematics of how wormholes could be stabilized. His work suggests that while it's far beyond our current technology, the idea cannot be ruled out. If wormholes are real and we one day learn to control them, humanity would face a future unlike anything imaginable. Galactic travel would take minutes instead of millennia. Time itself could become a frontier we explore, not just endure, but it also raises profound questions. Who would control this technology? Could civilizations alter history, or would they respect the flow of time? Would wormholes unite the universe or shatter it into chaos? These questions remind us that wormholes aren't just about science, they're about philosophy, ethics, and the very nature of existence. So are wormholes real gateways across the universe, or just a clever mathematical trick? For now, they remain one of the most captivating mysteries in physics, but remember, the math works. The idea is possible, and again, what once seemed impossible has eventually become reality. So maybe the real question isn't, do wormholes exist? It's, when we finally find one, what will we do with it?